Alright, so this is the final video covering content in Chapter 8 of the textbook. And after this, when we go into Chapter 9, we start to combine the geometric and linear growth and decay, and we need some added tools to be able to work with those beyond just recurrence relation because we can't create a rule. So we introduce those tools, in particular a really important thing called the finance solver with your CAS over the course of the second half of the topic. So this is the last section of Chapter 8 in the Cambridge textbook. So we want to look here at the idea of nominal versus effective interest rates. So compound interest rates are usually quoted as annual rates. In fact, I would say pretty much always quoted as annual rates, even if the compounding period isn't yearly. So usually the question would say, you know, interest is compounded at a rate of 5.2% per annum compounded monthly. Okay, so it's still a per annum rate. You need to then adjust it. That rate's called the nominal interest rate, the annual interest rate. Okay. So what we understand though, and what we've seen in some examples in previous videos, is that if we compound the interest only annually, we'll earn 8.3% interest per annum. If, however, we compound the interest more frequently than that, then we're going to earn, we saw that the balance of the account grew more quickly. So we actually end up earning slightly more than 8.3% of interest, if 8.3% is our nominal, i.e. annual interest rate. So what we want to think about here is how to calculate what we call the effective interest rate. So in practice, if I'm compounding my interest more frequently than annually, I'm actually going to end up earning what is effectively more than 8.3% in a year. So what we want to be able to do is work out how much. So let's just have a look at the situation so you can sort of see what we're talking about here. So we have done a little bit of playing around with changing the time periods, but just to be clear about the different time periods you might need to be working with. So obviously compounding annually, that's just one compounding period per annum per year, and so the compounding interest rate is just the nominal rate. If we compound twice yearly, that would be 2 compounding periods per annum, and so to work out the twice yearly interest rate, we would need to divide the nominal rate by 2. If we're doing quarterly, and we've done some examples using quarterly, we need to divide the nominal or annual rate by 4. If it's monthly, we divide the nominal or annual rate by 12. Now, fortnightly and weekly, there's not exactly 52 weeks in a year, but for the purposes of calculations in further maths, if you are required to calculate interest compounding weekly or fortnightly, we would assume that a year has 26 fortnights and that it has 52 weeks. And daily, we don't worry about leap years. We assume that the years have 365 days, so we would need to divide our annual interest rate by 365. Okay, so let's just have a look at an example that's going to lead us to this idea of effective versus annual interest rate. So Mark wants to take out a loan of $3,000, which he plans to pay off in 5 years. He's considering 2 different offers. Offer A is 5% per annum, compounded monthly, and offer B is 4.8% per annum, compounded fortnightly. So in offer B, he gets a slightly lower interest rate, but it's compounding more frequently, and we know that that means ultimately we do better. So we want to be able to compare these two things, and this is where the effective interest rate is going to be really important. But for now, we're going to work out not the effective interest rate, but what actually happens with the 2 different loans. Okay, so Mark wants to take out a loan of $3,000, so that's our V0. He plans to pay it off in 5 years, so that's N, although N will count in different time periods depending on whether we're looking at offer A or offer B, and he's looking at the 2 different offers. Okay, so the value offer A is compounding monthly, so that means N is in months in this question, and that means our interest rate is going to be 5 divided by 12. Okay. Oops, Control Enter, sorry. All right, so that's a recurring decimal, so I'm going to be careful about how I work with that with my CAS so that I can still be nice and precise. So we know that uppercase R, the multiplying factor, will be 1 plus lowercase r, so 0.4166 recurring over 100. So I'm going to use my CAS to work that out, and I'm going to be nice and precise because I'm going to use this exact answer here and divide that by 100, and to get a nice exact multiplying factor that we're going to need to work with. So 1.004166 recurring. So it's important to get it exactly in our CAS so that we can then use it in our next calculations nice and exactly. So we want to calculate the value of the loan after 5 years. So if n is in months, 5 years is 60 months. So this is going to be the value. So let me just write out the formula first. So value after n months is going to be the principal value, which is 3,000, times the multiplying factor, which for monthly is 1.004166 recurring, and it's going to be that to the power of n. So that's our general rule. If we want 5 years, we want not V5, sorry, we're in months, so it's V60. There's 60 months in 5 years. So that's going to be 3,000 times 1.004166 recurring to the power of 60. Okay, so let's work that out. 3,000 times, now this is why it's important to calculate your R value in your CAS, because I'm going to go up here and press enter to copy that, so I'm working nice and precisely with that interest rate to the power of 60. There's no reason not to. It's quicker with your CAS to work precisely than to type that number out again and round it off, and it's less accurate. Okay, so we're going to have $3,850.08 using offer A after 5 years. Okay, so now let's consider offer B. So B is a fortnightly rate, so N is in fortnights. Okay. That means my rate, it's 4.8. We're going to need to divide that by 26 because there's 26 fortnights in a year, and that's an annual rate. So 4.8 divided by 26. Okay, so again, that's not a nice number. So that's 0.1846. It doesn't even repeat. It's just not very nice. So we're going to be nice and precise about how we work with that in our CAS. So 0.1846, etc. over 100 is our multiplying factor. So let's work that out nice and precisely here. 1 plus, I'm going to take this number here, divide it by 100. Okay, so it's 1.001846, etc. Okay, again, we're going to work nice and precisely with that in the equation. So in this situation, our value after n fortnights is going to be $3,000 multiplied by our fortnightly multiplying factor, 1.00, sorry, just 2 zeros, 1846, etc. And it'll be that to the power of n. So we want to calculate the value of the loan after 5 years, and we're working in fortnights. So 5 times 26 will tell us how many fortnights there are in 5 years, 130. So this is V130. So it's 3,000 multiplied by 1.001846, etc. to the power of 130. Okay, so that's going to be 3,000 multiplied by, so again I'm going to go up and get that nice exact number, that value to the power of 130. Okay, and we get $3,812.90. Okay, so even though offer B compounds more frequently, that doesn't seem to outweigh the slightly lower interest rate. We actually still get better money with option A. However, I want you to be careful about what the question's asking you. He wants to take out a loan of $3,000. So he actually, in this case, wants the lower value. Okay, so the loan means he wants the lowest value because he has to repay that money. Okay, so be careful about the question. If this was an investment, he would definitely be going with offer A. He's earning more interest. But with a loan, he's paying the interest, so he wants a lower total. Okay, so therefore he wants offer B is the one that he should go with in this situation. If it was an investment and he was putting the money in the bank and earning that interest, then he would definitely want offer A. So be careful about the question. Okay, let's have a look at a different model, similar kind of idea, looking at comparing the same loan with slightly different compounding periods. So this time we're going to stick with the same interest rate. So we're going to start with a principal value of $8,000, a nominal, i.e. annual interest rate of 6%. Okay, so if we were to do that, we're going to simply increase by 6% once at the end of the year. So multiplying by 1.06. Okay. If we were compounding per quarter, we'd first need to work out the quarterly interest rate, which is 0.15. And so that means what's going to happen here instead is we're going to multiply by 1.015 4 times throughout the year. And as we've seen in a number of examples by now, what happens is because we're compounding more frequently, every time we compound the interest, we're calculating interest on interest. And so ultimately, as you can see here, we get to a bigger value. This value using still 6% per annum, but compounding quarterly, we get more money at the end of the year than we would have if we just compounded annually. And we see the same thing happen when we then look at what happens monthly. So it's still the same 6% interest rate. Dividing the 6% interest rate by 12 gives us a 0.5% interest rate per month. So that means what we're doing this time is we're multiplying by 1.005 12 times. Okay, etc. And ultimately, again, compounding more frequently, we again end up with slightly more money. Okay, so the more frequent the compound, the more you're going to end up with. What this means, though, is that if we only compounded it once, over the course of the year we earned 6% in interest. But compounding quarterly, we earned a bit more than 6% in interest, and the effective interest rate is that percentage. What percentage did we actually earn by doing it this way? Okay, and similarly, a bit more again for the monthly. So we can see from the table above that the more frequent the compounding period, the faster the value of the loan increases. We can calculate the total interest earned by subtracting the principal amount from the final value of the investment of the loan. So if we subtract the principal amount, which was $8,000, from each of these numbers, we can see how much interest we've earned over the course of the year, which is slightly different. And then the effective interest rate is essentially, well, what percentage is this of the $8,000? So 480 divided by 8,000 times by 100% to change it to a percentage, that's 6%. When we only compound it once, all we did was earn 6%. However, when we look at that for the quarterly interest, okay, work out that value as a percentage of the original principal, it turns out that actually effectively over the course of that year we actually earned 6.14%. And when we look at the monthly compounding situation, so working that value out as a percentage of the original principal value, we find that we earned a total of 6.17% of our original value over the course of that year. So these would be these are the effective interest rates. Okay, so annual nominal interest rate of 6% compounded annually, effective interest rate of 6%. Nominal interest rate of 6% compounded quarterly, effective interest rate is actually 6.14. We earn a bit more than 6%. Annual or nominal interest rate of 6% compounded monthly, we earned 6.17%. So we want to look to calculate, be able to calculate the effective interest rate. Now there is a formula, and it's really horrible, and it's on the formula sheet in Further Maths, but there's absolutely no way you would ever use it. Having said that, we're going to do it once because it does still appear in the course, but it's completely moot given that we're working with a CAS in this course. So let's just see, all we would need to do is substitute all the relevant information into this particular formula to give us our effective interest rate. So calculate correct to 2 decimal places the effective annual interest rate if an investment earns 5.2% per annum, compounded weekly. Okay, so that means that's our R value, 5.2. So this bit of the formula is about working out the weekly interest rate, because that's about doing, so R on N is 5.2 on, what are we doing, weekly. So weekly means N is 52. Okay, so 5.2 on 52 should be 0.1. So that's 0.1% per week. So in terms of using this formula then, our effective interest rate, which we can just write as R with a subscript of EFF for effective, is actually, so I'm going with the formula up here, it's 1 plus R on N, which I've actually worked out R on N here, that's 0.1. So it's 0.1 over 100 to the power of N, which is 52, and then take away 1, and then multiply that by 100% to get it as a percentage. So if I type that into my calculator, so I'm going to have 1 plus 0.1 over 100, and then we've got that to the power of 52, and then we are subtracting 1, and and then we're going to multiply that by 100 to change it to a percentage. We want 2 decimal places, so that to 2 decimal places will be 5.33%. However, we can get our CAS to do that for us, and we don't need to utilise this formula that still appears on the formula sheet. So the quicker way to do that with our CAS would be to make use of some of the finance options in the CAS. So it's to press menu. You've got the key press listed here. So you have menu, 8 for finance, 5 for interest conversion, and 2 for effective interest rate. And then all you need to tell it is the nominal rate, comma, and then the number of compounds per year. Okay, so in this case that's 5.2. So if we do example 2 using the CAS, the nominal interest rate is 5.2, comma, and then we need to tell it how many times we're compounding per year. So it's a weekly compound, which means 52 compounds per year. Enter, and it will give us the effective interest rate. Great. Okay, so let's then have a look at 2 further examples. David needs a loan of $28,000 to purchase a new car. His bank has offered 2 different loan options, Loan A 8.8% per annum compounding monthly, and Loan B 8.5% per annum compounded weekly. By comparing effective interest rates, decide which loan David should choose. So when we looked at this sort of situation earlier, we actually calculated how much he would owe after 5 years and made a decision from that. We actually don't need to do that. If we just look at what the effective interest rate is for the loan, we can compare the interest rates and decide which is the better option. Okay, so for Loan A, the effective interest rate, so I'm going to use my CAS, so again it was menu, 8 for finance, 5 for interest conversion, and 2 for effective interest rate. So menu 852 is a key press you should become familiar with. And then we need to give it, so we don't write CAS syntax on the paper, so you're not going to write what you type in the CAS on the paper, you're just going to write down your answer. So for Loan A, the interest rate, the nominal rate is 8.8, comma, and then compounding monthly, so that means 12 compound periods in the year. Okay, so the effective interest rate is, now this isn't the final answer, so it doesn't tell me how I should round it. I just want to be able to make a comparison. So 2 decimal places should be more than enough here. 1's probably enough as well. We'll see. So 9.16% for Loan A is the effective interest rate. So let's have a look at Loan B. So for Loan B, menu 852. Our effective interest rate, the nominal rate is 8.5, comma, and then the number of compounding periods per year. So we're going to compound weekly, which will mean 52 compounds per year. And we get 8.86%. Okay, so then the next thing we need to decide is, do we want to be earning more? Are we earning the interest or are we paying the interest? And hence, do we want the higher effective rate or the lower effective rate? Okay, so this is a loan. So David is paying interest. So therefore, he wants to minimize interest. So this means that we're going to want the smaller effective interest rate. Okay. So therefore, in this case, Loan B is the better option. So Loan B is the best option for David. Practically over the life of the loan, he will end up paying 8.86% interest per annum as opposed to 9.16% with the previous calculation. Okay, example 4, Monique plans to invest $10,000. Her bank has offered 2 different investment accounts. Okay, so the difference here is Monique's investing. Okay, so Monique is earning interest. So she therefore wants the higher interest. So she wants the larger value of effective interest rate. Okay, so let's calculate our effective interest rates for the 2 different accounts she's got. So for account A, the effective interest rate, so menu 852, the nominal rate is 5.58, comma, and she's compounding weekly, so that's 52 compounds in the year. So her effective interest rate is 5.74%. Again, if you just gave that as 5.7, that's fine. It's not telling you how to round that answer because that's not the final answer. It's just giving you enough decimal places that you can make a fair comparison. Okay, so account B, in this case, menu 852, interest rate, nominal rate or annual rate is 5.53, comma, it's compounding daily, so 365 days. So the effective interest rate here is 5.69% to 2 decimal places. So she wants the larger effective interest rate, and so therefore account A is going to be best. Account A is best for Monique. Okay, so exercise 8G is the final exercise in chapter 8.